All right, so let's get started. First, are there any questions about anything related to the class? I'll turn the lights down. Are there any class-related questions? Yes?
So if I have a tuple, u equals x squared, x plus 3.
What? Slow down, slow. Okay. He has a tuple. U equals
X squared, x plus 3. And I want to evaluate it at x equals 4.
Okay. You have to, this question is given a tuple. Why did I open that? No need. Sorry, double clicked on that. So given a tuple x squared, x and x plus 3, how can you replace x by 4? So you cannot, what you have to do is make a new tuple that you get by evaluating each of the entries in this tuple at 4. And I'll show you how to do that. You can do a tuple of, let's see, we'll call the entries A. So A, and you can do x equals 4. In case there are many different indeterminates, like x, y, z, theta, you have to be, it's best to be explicit about what substitution you're doing. So here, really you don't need to put the x equals. I think in this case it will choose the first variable, but it's always best to be explicit like this for A and U. I don't think I need braces or anything around this. And there you are. So that's what you do. You can't like change the tuple, the entries in the tuple you shouldn't change. So, or you can't change actually. And there's no like, I don't know, like magic thing you do that suddenly replaces all the x's everywhere in the universe by 4. But what that does is give you a new tuple. It doesn't change the existing tuple, of course. That still has the property, the x is still unevaluated. Okay? Other questions? Yes?
Without your email, is there a way of telling if you grabbed our homework or not? Because I finished on, I was getting down to the edge of 6 p.m. on Friday, and then I stopped.
I grabbed on Monday, so
is there, because it says anytime after Friday,
yep.
But if I would have known that there was more time, I would have.
I always send an email when I gather it.
Okay.
So if you haven't seen
if you
haven't seen the email, then I haven't gathered it yet. Okay. Okay, so let's see. What's next? Homework. I collected it all. The grading's been assigned. There's new homework available. Okay, so if you don't see the results of that in your project, then you definitely want to contact me. Yes?
So is our homework grade the average of the 3 assigned?
Yes, unless, of course, you disagree with one of the people who graded, and then you make an argument, and then we change that one. Otherwise, it's the average of the 3. And it's good that it's 3. For example, somebody emailed me today and they said, hey, 2 people gave me 19 out of 20, and then the third person gave me 12. What the heck? And so they were surprised and unhappy. Obviously, it's unlikely that 2 people are going to give you an almost perfect grade and the third gives you 50%, and it's correctly graded. So such things, as you should know by now, get looked into. Yes?
And if one person didn't grade our homework, would you know that, or should we? I had 2 that graded and then 1 who just, I looked at the thing.
I think that will be, the scripts will not find it, then we'll look by hand to see, and if there's nothing there, then we'll use the 2 grades. And that person will lose credit for not grading. Okay, next question. I felt like there was another question. Nope. Okay, let me show you the new homework assignment. Homework 6. So here's homework 6. It's mainly about doing the first rough draft of your project. There's a problem 1, which is several people in the class did exactly this project during class last time. So you go to GitHub, make an account, which you already have done for a previous homework, and then you fork that project, and I give you the URL, and you do a few other things. But it's literally like what we were doing last week. Some of you have done it already, more or less. Okay, so that's problem 1. Problem 2 involves making a Git branch and then pushing it to the repository that you made in problem 1. So again, that's almost described word for word in the lectures from last week, although I didn't actually completely do this. So you'll have to do a little bit of searching on your own to figure out how to do it. That's problem 2. Problem 3 involves choosing some functionality in Sage. And my example here is compute the product of a bunch of numbers. But there are other things you might do. And then try to figure out how it works, okay, by looking at the source code of Sage. And to give you some structure to that question, I've given some specific questions that you can answer. So in the particular case of prod, the very first step is you type prod with 2 question marks after it into Sage. And when you evaluate that, it will show you the source code for the prod function. And in particular, it shows you the file where it's defined. And so then you can open that file and look further. The specific questions are to describe what the function that you're looking at does, give an example that shows how it works, and then when you look at the source code and the function's documentation, is it good or not, in your opinion? And you're the best judge of that because the documentation should be aimed at you. And does the source make any sense? When you actually look at the source code, does it make any sense at all? Is it completely confusing, etc.? And then finally, generally speaking, there's kind of a speed situation with functions that are in Sage. Either they're toy implementations, I hope there are very few of these in Sage, where they're really slow, but they work. Or they're solid implementations, but they're not like, wow, this is the fastest implementation in the world or anything. But they, kind of get the job done. Or they're really impressively fast. See if you can say something about what the function you chose is like. For example, if the function you wanted to choose is prime, something that tells you whether or not an integer is a prime. Is Sage's isPrime function impressively good compared to other programs? Is it just like a stupid thing that basically checks for divisibility up to the square root of your number, and hence it's just a toy example, but it works and is correct? Or is it just sort of like, I don't know, intermediate, somewhat good, but not really that serious? Okay. So figure that out for the function or functionality that you choose. Then problem 4 is the first rough draft of your project. And I've clarified a few things here. This is not a complete grading breakdown, but a key thing regarding it being a rough draft is when the person or people who are grading your problem 4, they will not take off any credit for typos or bugs in code or basically technical stuff that goes away with polish. So for your rough draft, don't worry one speck about run-on sentences or commas or spelling mistakes or anything like that. You will not lose a single point for that sort of thing. What will be more important is that there's some evidence that you put significant effort towards your project. So you can satisfy that by putting significant effort. And the second is, so you need some sort of criterion to decide whether or not a project has any worth. And I decided on this one. So this is just like a small subset of points in a certain problem for now, but a criteria that's subjective is, does the project have any potential to be useful or interesting to other people? Okay, so there's an actual thing. So for example, your project on rotating polygons, that would be useful. I wanted to do that during my lecture when I was talking about graphics. So your project to add that functionality would be useful. Or somebody's project on computing a covariance matrix involving a lot of financial time series. That could be useful to somebody trading financial instruments, etc. Whereas, let's see, what would be a project? Can anybody think of a project that would be utterly useless? Maybe it's degree. I mean, probably nothing's utterly useless, but I don't know. A project to list the first 100 integers. That would be really just pointless. Who cares? Or like, I don't know, stupid things like that. Count the number of even integers up to n. I mean, all right, so that's it regarding homework 6. Any questions about homework 6? Okay, moving on to, okay, so we've got general questions, homework, building Sage from source. Okay, so what's the situation there? So first, I want you to build Sage from source. I checked right when I was writing this, and 8 of the 40 people in this room built a copy of Sage in their project, which means that 32 people didn't. So you're supposed to do that by now, so do that. soon. You're going to have your own personal copy of Sage, which to build is very easy. In your project, you just type, it looks like I forgot to, let me edit this for a second. I have to indent this so that it looks like terminal code. So all you have to do is type git clone, and then you'll get the Sage Git repository, cd into it, so this is done in the terminal, and type make. And then you come back in 2 hours, and it's done. And I want you to kind of think about your Sage install as, well, a Tamagotchi. I don't know if anybody remembers these, but they're like a little digital pet that you want to keep healthy. But you might feed it with interesting changes. You can make it into a schizophrenic pet by branching your Git repository, so you can switch its personality, whatever. So you're going to have your own personal little Sage install that's sitting in every single person here's project. Okay? So if you haven't already, you want to type these 3 commands so that you will have your Sage build start. For example, let's check on my Sage build, which I started at the very last minute of class on Friday. So I'll go into the terminal. I'll make this big so you can see it. I have all kinds of files here, but in particular, it'll appear in a directory Sage. And let's look at what's there. If I type ls, there's some files there. If I type git log, I'll see that there's a Git repository. If I type git status, I'll see that. If you look in the file, there's a directory called logs, and that contains build logs. So if we look inside of there, we'll see that there's an install log. And if we look at that, that logs all the steps of building Sage from source. So let's just open that up for a minute. It's actually a very long file, probably. 129,000 lines. That's going to test the limits of this editor. Let's see how that goes. Oh, okay, it worked. By the way, in case you're curious, it's actually impressive that a web browser-based editor can easily deal with 120,000 lines, for what it's worth. There's a lot of tricks going on in this editor to do it. Like, this scroll bar is completely faked. It doesn't actually store the text that we're seeing here, except for a little bit of it. It's not actually in the DOM, the document object model. It's stored in the JavaScript data space. So what it does is, as you're scrolling, it pulls little bits of the appropriate text on each side and then renders them as you go. So it's pretty cool. There's an amusing blog post by the author of CodeMirror where he talks about, it's called, I think, A Tale of Two Scroll Bars, where he talks about in detail how he fakes the scroll bars that you see on the side. In any case, here's this long log, and for every single component that gets built as part of Sage, it's just showing you the output of basically a very large number of make commands and other similar commands. And at the very end, you see this. It took 187 minutes, and our Sage build is complete. And there's some other remarks here. Worry about. Okay. So hopefully that's what you'll see at the end. So it looks like it actually, I said 2 hours, but it looks like it's 3 hours almost. If you build in parallel, which you can do by setting a certain flag and having the quota for the number of cores increased, then it could be substantially faster. There's a lot of support for building in parallel in Sage itself. But the default quota for projects doesn't really give you much. Okay, so that's it. The most important thing, though, at this point, is to run Sage to see if it actually works. And here's what you have to type. If you just type Sage in this directory, it's not going to run the copy that we built. There's a path. When you type the name of a command, there are a list of directories that the command line looks in to decide what to run. So if we just type Sage like that, it's going to run the copy of Sage that's installed system-wide, not the one that's in my current directory. There's a command called which. It's yet another terminal command. It tells you the exact path to the command that's given after it that it's going to run. So if you type Sage, that's the command it's going to run. If you type ls, that's the command it will run, etc. And there's a variable called path, echo $path will print it out. It's a colon-separated list of directories, and that's the search path for running scripts that you write or scripts that are installed system-wide. And by default, it typically doesn't include your current directory. It won't in Sage Math Cloud. People consider it a bad idea to include the current directory in the search path because somehow it makes it a little too easy to, I don't know, it's kind of a security risk and possibly a little worrisome that if there just happens to be a command called rm or ls or something in your current directory and you type ls, you don't get the one that's system-wide, you get the one in the current directory, which could be a problem. Although it depends on where you put the current directory in this list. In any case, to force the command line to run a specific command in the current directory, you have to do something. Either you can add the current directory to the path, or you can say /sage. The dot means the current directory. So this is an absolute path to the sage command. So it will run the one that's in the current directory. So I put a dot and a slash right there. And then I run it. And this runs the one that we just built. And it's sage 6.1.1. I'm going to write that down right here. Dot slash sage. And probably, has anyone here heard of the website /dot? Yeah, probably their name was somewhat inspired by the fact you type a dot slash in the current directory. I don't know. Okay, so Sage works. I was fiddling with it a moment ago, and that's why it says hi. So let me get rid of that. Just pretend you didn't see that. Okay, Sage works, and it's completely fresh, vanilla, installed from the latest Git repository hosted on GitHub. And you might notice the version number is different, the banner is a little bit different than the system-wide Sage install. Also, the collection of there'll be no optional packages installed in this. It's a fresh, clean, vanilla install of Sage. So good to have this. You can type commands just to test it out and see if it's working. And it is. Good. Okay. Also, in the worksheet from last time, I explained how, if you want your worksheets to use this copy of Sage, what you do. And it's documented in the FAQ. All you have to do is make a directory bin, which is in the path, and then make a symbolic link from this Sage command to that directory. Since I'll just show you that. So in the bin directory, you make a symbolic link from Sage command to this directory. And that's the obfuscated looking stuff you type. ln makes a symbolic link. So it's kind of standard thing in Unix that doesn't really exist in Windows. But when I do that, what will happen is now there's a file called Sage in this directory, and it's really a pointer to the Sage command I just ran a minute ago. And bin is in the path, and that's stem. You'll have to make that directory, by the way. Again, there's a step-by-step list of instructions for doing this. I think it's actually listed right here under restart. Yeah, right here. Well, okay, you have to know a little Unix to be able to read that. But in any case, once you do that, then when you run the Sage command from anywhere, you have to log out and log in for that to be the case. But if you log out and log in, and then run the Sage command from anywhere, then you'll find that it runs your personal copy of Sage. Moreover, if you want your personal copy of Sage to be used in worksheets, you have to, in addition to making the bin directory and making this link with the ln command, you have to restart the worksheet server. This just kills the current Sage worksheet server and makes it so that newly started worksheets will use your new copy of Sage. So I clicked that button. It stopped somebody here was talking about making APIs. Is it you?
Yeah.
Yeah, so it just killed a Sage server, which has an API for serving up Sage, and it started it up again, but it's now going to use our new copy of Sage that we just built. I hope. We'll see. So now I will create a new worksheet just to see if it worked. New. Yeah, it's still the old session. If you want to, you have to click restart on the old worksheet for it to start using the new server. Alternatively, you can click in project settings. You can just click restart here. That will kill absolutely every process running as this user and then start everything up cleanly and freshly. So That's kind of like the button to fix most problems, and also it just kills everything cleanly. Okay, so let's try it out. I'm going to click New, Test, hopefully New, Sage Worksheet. And it's a little slow because it's probably, well, there are a couple of issues. Well, let's see what happens. One reason it would be slow would be if it doesn't work. It's possible. I don't think this is going to work. Crap. Let me check something. Should work. Hey, it worked. Okay, it worked fine. I was just paranoid because I'm an impatient paranoid person. So let's see if this works. That looks good, but most importantly, let's see if the version 6.11. So it's really our custom version of Sage. We did it. And there's another thing you do. There's a variable Sage root, and that's the root of your Sage install. So here, in my new version of Sage, it's in my home directory. Whereas, if we look at this exact same variable in the old running worksheet that I started in the context of the class, that's the system-wide Sage install. Okay? So this is useful if you want to use worksheets, maybe do something with graphics, like, I don't know, rotate polygons, and you want to see your changes in a worksheet in your own copy of Sage. Because you can't change the system-wide copy of Sage, since that would change it for everybody, and you don't have right access to it. Okay, any questions? Yes?
How do you go back to the system-wide once you're in your own copy?
So here's what you could do. Delete that command Sage that's in the bin directory. What command would you use to delete it if you're using the terminal? RM. Or you can also just use the graphical browser and delete it the normal way. But basically, go in the bin directory and just go to the Sage thing, click on it, and toss it in the trash. And then go to Settings, go to Restart Sage Worksheet Server, and now what it'll do is it'll make it so now all future worksheets or restarted worksheets will use the system-wide version of Sage. Okay, and let's just see if that's really true. This one's still running using the new version of Sage, but, and I'll show you a bug which will go away soon. If I click Restart, that kills the Sage process. And now if I try it again, the first evaluation probably won't work because of a bug, but then ever after it will work if you just try it again. And now this should be the system-wide one. Yep. So watch out for that bug though. Sorry. When you do restart, the very first evaluation just doesn't work. It's been on my to-do list to fix that for a while. So just evaluate again. Yes?
We can define our own class in Sage. So
Yes.
when we download our Sage and define class, does it remember?
Yes. You can change absolutely everything about Sage and read all source code of Sage and all of its dependencies, which are all there. And it will remember it. You can do anything to it. Let's do something really stupid to it to illustrate this. Okay, so our Sage install is in this directory Sage. And here's the source code of the Sage library. It's in a subdirectory, src. And the most interesting thing is in the Sage subdirectory. And here's where it gets interesting. Okay, so the directory I'm in is, I looked at the root of the Sage install, which is called Sage in most cases, if you git clone it. Inside of there, I went into the subdirectory src, which is a shortcut for source. And inside of there, I went into a subdirectory called Sage. So it's not too far down to find. And it's pretty natural that you find the source code of Sage in a directory called source Sage inside of the Sage repository. And this looks like math. Finally, you see some math in this class. There are a bunch of directories here that involve math, like matroids, schemes, graphs, geometry, games, commat, tensor, symbolic. So this looks very math-like, plotting, monoids, etc. So let's say we want to do something. I'll do the simplest possible thing first. I just show you that I've affected Sage. And then we'll move on to more other things as time progresses. Okay, so I'm going to do something really simple. There's a file all.py which just gets read in when Sage starts up. I'm just going to put a function in, or I'm going to put a little print statement in. That's it. So that every time we start Sage, it'll print something out. Okay? So let's try that out. I'm going to just open the file all.py. There it is. And at the very bottom, say, I'm going to put print hi. I want to name my copy of Sage. I'm Tamaguchi. Okay, there you are. So that will print out when we start up Sage. I'm going to purposely make a couple of mistakes. If I just type Sage right here, what's going to happen? I'm just going to run the system-wide copy of Sage because I deleted it from the bin directory. But I can give the exact path. So /sage. This is not going to print the message. Unfortunately, currently with Sage, if you make changes to the source code, you have to give a flag when you start up Sage for it to notice those changes and make them take effect. It's kind of a compile flag. Otherwise, it just ignores the changes that you've made. This is not a priori the way it will always be. In fact, it would be fairly easy, probably a week of hard work, to change Sage so that it would immediately notice any changes you make in here. But nobody has got around to doing that. Maybe one of you will. I don't know. So for now, and for the last 7 years, or more, actually 9 years, you type sage-br, which stands for build and then run Sage. Okay? What that does is it will look at all the files in the source Sage directory. Any Python files, it'll copy them to the appropriate place so they will get noticed. Any Python files, Python is some, or C programs or C++ files, that stuff will get automatically compiled as well. So you don't have to know how to do any of that to compile Sage. So when you make changes to any part of the compiled code, the Python code, whatever, any part of the main Sage library, you just do -br when you start it up. I think you can also type make as of very recently, which is kind of a natural thing to do, but I know this works. So what it's doing is it's checking to see if anything's changed. And indeed, I changed the file all.py, so it does some compilation of it, and so on. And now it started up, and it printed that message. Okay, so we've now changed Sage. And that's just a really simple example of changing something in Sage, but you can change anything. Let's change something else. So somebody think of a function in Sage that they've used before. That's we'll see whether or not it. So there's functions that are part of the Sage library, and then there's other functions like in Python itself. Those are a little bit harder to change because you have to rebuild Python from source, for example. But you can do that too if you want to. It's not terribly difficult. Okay, let's find the factor function and change it. So as usual, if you want to find a function in Sage, often it's useful to do double question mark. This is also just a general IPython thing. Double question mark shows you the source code. I do not see the location. That's really weird. For some reason, it did not tell me where it is. There's a useful command, search_src. And what that command does is it will search through, takes a little while, it'll search through all of the source code of the Sage library for the string that you put in the source code and show you what file it appears in and where. Obviously, this can be handy. So it shows us everything that starts with, that has def space factor. Okay, and it looks like the one that matters is, is that ECM one. That's actually a highly technical thing. See if we can find the top level factor. Command. I saw something factor int. Something irrational. This is for so this file rings integer.pyx. This is factoring for the integers. And it looks like there's a very general factor function right here. So the first thing is factor is more complicated than you might think. It looks like there's like 5 different functions called factor, at least. I'm pretty sure that when you call factor, it's calling this one right here, and then this one delegates to various other factor functions. I think that because I wrote this function. So let's look at the file arith.py and see if we can dig into the factor there. By the way, doing double question mark should show the location in the source code. Maybe that only works in the worksheets, though. Let me just try really quickly. Yeah, so it should be that it says file colon and it gives the location in the source code. And that is working in a worksheet. I don't know what the deal is with the command line. There it is. And it's in arith.py. Okay, so let's take a look at this function. So now I'm going to open it by just exit out of here, open source sage, I think it's rings arith.py. And there it is. Make it way bigger so you can see it. And then somewhere in here, search for factor. And there's factorial, which is an amazingly fast function, by the way. You can compute the factorial of 10 to the 7th in like a second, or 2 or 3 or 4. Actually, in like 4 seconds on the Google nodes, and 9 seconds on the UW ones. Okay, so here's factor. And then it's really big. There's a lot of documentation. And then finally, you can see that it does some things. So if your input is an integer, then it calls the factor method on your input. Otherwise, it just checks to see if there's a factor method on it by trying to call it. And if that fails, it gives you an error. If it fails with an attribute error, if it fails with a type error, it gives you a different error. Or try something else, actually. So it looks kind of messy, but the problem is it has to deal with factoring different types of things. And you might define a whole new object, a whole new class from scratch, and have a factor method in it. And it'd be nice if when the user says factor of foo, and foo is an instance of your class, then it calls foo.factor. And this will in fact happen. Okay, so let's change something. Any suggestions for what we might change about factor? Remember, this is really just a top-level function that delegates to other functions. So we could do something evil, like change it to, I don't know, factor 1 over n instead, or something silly like that. And then just see that it's completely funnily broken. We can have it factor n plus 1. How's that? Okay, just right at the top, I'm going to put n equals n plus 1. All right, now I'll go back to the terminal. Do /sage. Remember, I have to type something, otherwise it's not going to notice my change. What do I type? -br, a completely arbitrary thing I made up. There it is. Type that. Actually, let me try make, because I think that Andrew Ohana recently added that. That looks promising. Okay, cool. So make, yep. It looks like make also fixes things. Does, don't do make. It looks like it's going to do all kinds of work. Okay, sage-br. Make is a bad idea. Because it's going to go through and check all kinds of documentation and stuff. All right, so let's try factoring the current year. Oh, garbage collection. Okay, factor. Come on. Okay. Factor 2014. And hey, look at that. That's pretty evil. But notice we can change anything we want. It's often useful when you're trying to understand how a function works to be able to put in print statements just to see like what it's doing, put little timing stuff in. You don't understand how it works, so you just put some print statements in. All you have to do is literally just put them in the code and do sage-br, and you'll see their output. So that's like a handy first step in getting a feel for how things work. Okay, so we've now messed up our Sage install. And this is a Git repository. So if we want to see exactly what we've done to our Sage install, we can use Git. Git space status. That will tell us what things have changed. Sorry that it kind of went by there a little quickly. But notice that it shows that these two files have changed, and indeed they're exactly the ones that we changed. We can also type git diff, and it'll show you exactly what lines changed in these files. By the way, extremely quick aside, there's a program called tmux. If you use the terminal a lot, it's well worth learning about this program. Notice I'm in a terminal, And I can do flashy things like splitting the screen and getting another terminal, splitting the screen again, rearranging the windows, I don't know, cool stuff like that. So if you see like, I can have it type ls in all of them at once, etc. If you see a person that uses Unix a lot, you'll likely see stuff like that happening, where they have all kinds of consoles and are switching between them, and it's all inside of a terminal, and it's nice and colorful, and they're not using a Windows system at all, and they can just detach from it and reattach to it later. They might be using tmux. There's another version, another program, Screen, which is similar to tmux, but tmux is pretty popular. So you might want to look at this. It's very well supported inside of Sage Math Cloud. So that's my little commercial for tmux. Now let me close my windows. Okay, so if we do git diff, then we'll see the changes that we made. See, there's the one line that we added to the file all.py. And then there's the line that we added to arith.py. So we can track exactly what we're doing to our Sage install this way. And now let's say we want to get rid of what we just did. For example, that change to all.py was ridiculous. So you can do git checkout and then give a file name, and that will just check out the version before we started changing stuff from our local repository. And now if you do git diff, you'll see that only that one change remains. Okay. So that's the very, very basic workflow of how you can build your own copy of Sage, modify it, and see the changes. Now, that works really well when you're specifically looking at stuff that involves code that is in Python or Cython or something that was written as part of Sage. It can be a little more complicated to see what's going on when, well, let's say we want to understand how Sage factors integers. Factoring integers is an extremely difficult problem. And if you do factor, I'm going to make a big random number, so the fact that we added 1 isn't going to make much of a difference. Actually, I'll factor 2 to the power of 997. That would be easy, except we added 1, so it's actually really hard, I think. Maybe, so that'll just sit there running forever, really. I mean, I think it would take thousands of years. This is really factoring 2 to the 997 plus 1. Remember that, because we made that change. So if I kill it, I might look at the factor help and I'll find that there's a verbose option. And if you type verbose equals, say, 4, it'll give you very verbose output as it goes. Or not. Maybe I have to do verbose equals 8. Yeah, okay, there. So I said verbose equals 8, and now it's telling me about all these things it's doing, like trying to use something called IFAC to crack a composite, using something called the row method, et cetera, and it'll just like sit here printing out what it's doing for a long time. You might wonder, where is all this stuff implemented? What is it actually doing? I want to look at the code that it's running right now. So if you start digging around inside of the Sage library, you'll find that it's calling code that's, well, it looks like there's this thing factor int. So I'll open the corresponding file. Open source sage rings factor int.pyx. And here it is. And I've never seen this before, and I've never heard of Andrei Apich. But thank you to him, he wrote a file called factor int. And inside of it, wow, that's a funny word. Okay. But in here somewhere, there's going to be something for factoring integers. I think it has all kinds of clever specialized code for certain types of numbers. Yes. But finally, there's this function factor using Paris. And Paris is just a completely different program that happens to implement the kind of best generally available, very, very general purpose integer factoring code. It's not aimed at maybe cracking crypto systems, but it's generally very good overall. And when we look at the source code in a minute, we'll see that there's almost no code here. So all it does is import something else and then make an integer in that library and call factor on that. And now I know where to look to get the source code for that. Let me show you what this what this actually is, like what the code is there. It's just going to be one single call into some other library, which is a little disappointing. So it's libs gen.pux. And then in here, there is a function factor. And this, let's see, once we finally find, yeah, this is finally what happens when you factor an integer, as far as Sage is concerned. It calls factor without proof Sage. Okay, that's a new thing I have never seen before. So that's apparently defined. Geez, it takes a while to trace this down. That's annoying. So apparently there's yet another file. But at the end of the day, so now we'd have to look at misc.h and figure out there's some probably misc.c somewhere. At some point, there is a function that finally factors, and it's not written in Python, or here it's written as part of the Perry C library. So to actually look at the code that's doing factorization, which I have never done in my entire life, actually, you have to bust open the source code of Perry and then look in there to try to figure out where the factoring happens. And you have to understand like what the components of Sage are, how they're built, how to change them if you want to make changes there, etc. So it does get complicated. Fortunately, it's somewhat modular in that at least instead of having one system that's like 5 million lines of code, which could get kind of messy, the fact that I say it's in Perry means, okay, there's one program called Perry. It does factoring and some other things. You could just get it from the Perry website and start looking at it, follow their build directions, or build it as part of Sage, and it's like isolated. But the point is, the next step is that you have to get Perry, break open its source code, and understand how to build it as part of Sage. I am not going to show you how to do exactly that today. Instead, I'm going to take a step back, or we're going to take a step back, and ask the question, what is Sage? You're seeing lots of Sage, but what is Sage? So it's two things. It's a huge distribution of math-related software, like R, etc. There's lots of math-related software out there that's open source, all licensed under a GPL-ish compatible license. So that's one thing it does. And it's designed so that without very much knowledge, i.e. you just have to type M-A-K-E, you can build it from source. When I started Sage, a lot of this software was out there, but to build it all together was an incredibly Herculean task in that I only wanted to build like 20 of the 100 things that we have in there now. And it took me about a month to figure out how to build them all together robustly. And so I figured it would be a good idea to make that automatic and easy for other people. Otherwise, people using open source math software at a serious level would be completely doomed, since most mathematicians don't have the patience to try to figure out how to build a whole bunch of different Unix tools and programs in the same place at once. And many of these programs are fairly small, or they have a small audience, and so they're not just in standard Linux distributions or OS X. They're kind of difficult to get them all in one place. So that's the first thing that Sage is. And the second thing is it's a big Python library. When we were looking at source code just now, the entire time we were looking inside of this big Python library. And by big, I mean it's really pretty big. I mean, I don't know, it's probably around 500,000 lines of code, and then lots and lots of documentation as well, like doc strings. So Sage is these two things. And by the way, as I mentioned before, because it's Python, you can install Python packages. For example, there's 43,000 of them listed at PyPy. It's also, one of the programs that's in Sage, and for which there's a nice interface, is R, which has thousands and thousands of packages. You can install those into your copy of Sage. And there's also, just to show you something that's more algebraic oriented, there's GAP, which does abstract algebra. A program you should definitely know about if you're, say, taking an abstract algebra course. And I'll show you some demos of this at the beginning next time, or maybe in a few minutes, which has itself hundreds of packages that you can install in Sage. So that's what Sage is. It's a distribution and a library. And both things, a lot of work goes into developing both of these over time. And the number one, so the distribution part is just pure computer stuff, pretty much. I mean, it's pure software engineering. Whereas the people that do a lot of that are really good at software engineering, and they put a lot of effort into it. And they don't really need to know anything from mathematics, except, well, nothing really. Whereas two, a lot of that involves math. In fact, quite a lot of the new library stuff, people write on the way to getting a PhD. And it's hard to understand half of it without a PhD. And no one person can understand very much of it. But it's pretty powerful stuff. Okay, so let me give you a little sense. Here's a picture of how people think of Python. This is the kind of batteries included idea. You get it out of the box and it comes with a lot of stuff. And it's lit up already because the batteries are included, unlike some systems which are very minimalistic. Python includes a lot, and then Sage builds on Python includes a lot more. So if we look in our Sage install at the upstream directory, which I almost don't want to click here because I know it's going to do that. But I just want to show you, if you type ls upstream, it will print out a bunch of names of compressed files. And these are the third-party packages that are included in Sage, except for the one that's called, actually no, they're all the third-party packages included in Sage. And there's a lot of them. There's got to be way more than 20. ls-1. Oh, sorry, upstream. So there's 86 of these. Okay, so now I'm going to tell you about a few. The next thing is to tell you about some of the notable components. And since we only have 2 minutes, I'm going to show you one of them. Let's see, which one do I want to show you for now? I will show you, okay, I'll show you Lisp. So here's a joke. I just checked a bunch of Lisp into the repository. Why? Python's easy. Other nerdy stuff. Okay, anyways. So one of the components of Sage, if you look at that big list, is ECL, Embedded Common Lisp. Has anyone here ever heard of Lisp? Yeah. Okay, so it's another programming language. And it's in Sage. It's a dependency for Maxima, which is the oldest computer algebra system, which was written initially in the 60s and carried forward many years. It's now used actively in Sage. Like when you compute symbolic integrals, it is running Maxima code to do that. When you compute Taylor series expansions, it often uses Maxima. So if you type %lisp at the beginning of a cell, it switches the cell into Lisp mode, and then it evaluates the code that you put there using Lisp. So here's some little examples. The first one is how so Lisp uses a different notation. Use parentheses and you put the operator first and you put the two operands, for example. Here's an example of defining two variables, and then in the next cell, running the corresponding code. Here's a more complicated example, which will show why I don't like Lisp as the main language for Sage. So this defines a function that finds all the factors of an integer. When you look at this, if you look at it long enough, you might decide Lisp is awesome or Lisp is not. But there it is. So you can just run it right inside of a worksheet. It works. So, and then here's an example of calling it. So you can factor a different number. Okay. I don't like it so much because I think if you take a random person and ask them to just try to read this and understand how it works, it's just hard. And I think that if you wrote a function in Python to find the factors of an integer, implementing the same trial division algorithm, you could write something that anyone in this room could just read and understand. Whereas this is not the case with Lisp. So in any case, though, it's one of the main components in Sage. So if you want to write some Lisp code and have that be used in Sage, it's not that hard to do because Sage includes Lisp. Okay, we're going to start next time. I'm going to show you some of these other systems like Peri, Gap, etc., Atlas, and it'll give you a sense of what Sage is built up from.